if you read the title, you know what the point of this is. But we'll go through and look at this. Y equals root x looks something like that. All right, y equals square root of x. If you want find the area bounded by that and the x-axis and the line y equals x minus 2. X minus 2 looks something like this. So we have the x-axis right there. We have that line and we have those three. So we're looking at this area in here. So this is slightly more complicated than what we did before. Why do you think? Well, all the other ones here, maybe we shouldn't have skipped the ones before. Maybe I'm skipping ahead too fast, but I think you can handle it here.
How do you do it?
When it doesn't what? Say that again? It doesn't connect. What do you mean it doesn't connect? Well, you mean because you don't like that the shading doesn't go down to there? That's the point here of this question, right? Like, what do you do? What could you do? What does a calculus person look like compared to a regular person? He has one of those hats, like the graduate thing or something, like he's smart or whatever, like one of those little things. It looks like a teardrop. He's crying about it. What do you do? You can figure out a way to do this, right? X-axis times x-axis times y-axis gives you what?
Gives you infinity.
Well, if we subtract these functions, remember, just think about the rectangles here. If I call this square root function f of x and this one g of x, part of it is f of x minus g of x, right? The rectangles here are f of x minus g of x, right? The rectangles up to here are like this. But at a certain point, what happens here? Like down here, it's not going all the way down to there, right? What? You're all talking at once. Which is nothing new, but you're all talking about this at once. You could do minus the little bit here, yep. Absolutely. Well, there's two ways. You could, for this particular one, this wouldn't be that hard because it's a triangle, right? And you could do, you're somehow going to have to combine two things. There's not going to be a way to get it in one expression. You can split it like this, yeah? A few of you said split it, I think. Take this little bit away over here. You could do that, right? You could do the integral from here all the way to here of f of x minus g of x, and then do just this part here, right? And combine that. The way I was thinking was this way that I drew here, this line here, splitting it into two. From 0 to what is this value here? It's 1, isn't it?
Yes. You are correct.
No, it's 2, isn't it? It's 2. You're correct. You're just agreeing. You're correct. No, you're not. It's 2, right? It has to be 2, because this is 2 and it's going up at a slope of 1. 4, you're going to split it into two parts. This part right here is going to be, we're going to add two integrals together, right? So we have from there to, what is this point right here? I think this is 4.
I don't know. Yeah, it totally is.
It totally is.
Are you sure?
I'm going to call this area 1 and this area 2 here.
It is 4. I'm going to say that it's 4. There is no way it could not be 4.
If you want to find the first area is actually pretty simple, right? Because why is it simpler than the second area? Because what? You don't need the second function, absolutely. Integral from 0 to 2 of whatever, f of x, right? Of root x. Dx. Of that first function. From 0 to 2. That's going to give you that yellow area, right? This is the This is the yellow part here, right? That's the yellow part. And what's the other integral then?
From 2 to 4.
2 to 4 of... Yeah, the 2 subtracted, right? We have to subtract them in the right order, right? The one that's on top. So root x minus 2. There you do need brackets around that x minus 2 so you don't make a sign error. That's the, well, I guess it's green now, but that's that part. You're adding those two areas together. Notice you're adding them because you have two separate areas. You're not subtracting them there, right? I'm going to assume that you can go and you are able to figure that out either numerically or analytically. I'm sure you are able to do that. The new part, let's not try it actually. In the interest of, well, no, because, I mean, if we're using our time efficiently, this is the new part. The rest of it is stuff you already have done. What you have to realize, though, is there exists another way to do this.
No way.
I've just been sitting here for the last 10 minutes. I did not tell you to, well, because we haven't had one where it would be easier to do this way. Take a horizontal slice. Instead of doing the rectangles this way with dx here or delta x, you do dy because you're going to look at the rectangles this way to the y-axis. You're going to do delta y times the difference between the two functions if they're written as functions of x or as functions of y, right? You have to switch these around. Y equals root x. This is a function of x. You need to change it so it says x equals y squared with two equal signs even, just for emphasis. No. And you have to change this one around so that it says y plus 2 equals x. Because you can look at it in relation to this axis here. The curves are the same. Okay, the curves are the same here. But you're going to do this to this axis here. So you're going to think about this all the way down to there. And you're going to think about right to here, right? This is 0. This is, what was this value? 2?
Yes. I'm not sure. I don't think we talked about it. It was 4.
Well, it's a 2, because the square root of 4 is 2, I think. Last time I checked. In this case, this is easier. It should still give you the same area, so we probably should have gone and solved it, but you can do that in a minute. You can set it up to the y-axis. Think about what each of the little rectangles are, what they are. There's one rectangle right there. It is, the width of it is dy, or delta y, right? This direction is subtracting the two functions, right? The difference between the two functions. When we set up an integral, remember that it comes from that sum of all the areas of the rectangles. You're going to do the sum from 0 to 2 on the y-axis now, right? And you need to use them as functions of y. Which one is the higher up function if you're talking about the y-axis as the y plus 2? It's this one is the greater function in that case, right? It's from you're looking at this one down to there, right? So you need to put y plus 2 minus, what's the other one called now? Y squared. dy, right? This is the key here is you're doing this to the other axis. These have to be y values. These have to be functions of y. This has to be dy. Why? Why is it y? Why? Why? Can you evaluate both of those, both analytically and using your calculator, and just confirm that you get the same answer both ways? And then try this question. And then we'll call it a day.
Can I call it a day?
You cannot call it a day.